응, 오빠 그럼 12시, 1시 잘 거야?
아니? 1시 좀 넘어서. 삼성 써야 되나? 삼성 쓰고 싶지 않나? 정편, 잠시만요. 안에 생각하면 여기다 세팅하면 또
이거 꺼야지.
Good morning, everyone.
Hey, Manoj, good morning, everyone.
Hey, good morning. Hey, good morning. All righty. It's been what, 3 weeks now? We had one tech day and I think we had canceled once.
Right.
Okay. I know Samir will join in a few minutes, he said. Okay. So just going through the agenda, we have some pending items, but I was thinking whether we should pick up from where we left on the tech day, specifically for the AI systems workstream planning and the goals for the year. So unless anybody wants to propose something else, the two more items that we have on our agenda remaining are of course same thing on the DC fabric orchestration ready. We can continue on that one also based on a discussion, or we can take it in any order you think is appropriate.
Okay.
The two more items that we had on the agenda that had left on the planner is computation memory and offloading AI workloads. This was something I think it was from ARM that could be a broader interest to CMS. I think this came from the CXP team. And from the workload team, the one more topic that had bubbled up was TCO model preview, I think, from
Right.
Nilesh. So these are the pending right now. Maybe we can start from at least seeing that, are there any agenda items that anybody wants to propose for future meetings?
I just had a quick one, Manoj, for the
Yes.
CMS academic research. I just wanted to propose that we funnel the academic research presentations to our work stream, but it's just like a 5-minute discussion, and then we can take it offline as to what people's opinion of that is. But if I could add to agenda at some point in time, that would be helpful.
Okay, let me just put that in there also. Okay.
As another item, if we can still encourage people who are doing any kind of performance analysis to share their findings, supportive of earlier presentations, or if they find something new. There are a number of CXL devices in the market now. It's likely people are working with them already. It's good to keep talking about them.
Yes. It's a very, very good point, Siamak. Maybe let me also chime in there in support of what Siamak is asking. As we start going through the AI systems configuration also, we'll see that some of the questions that keep coming up is that the actual performance of CXL or any other protocol that is proposed for the workloads, but also as compared to existing solutions. And now that we have CXL components available, now that we have the CXL solutions available, it will be really good for anybody who can bring forward performance numbers. For example, we had the UIUC command present along with Intel for the CXL.cache use case. It will be really good to get more details behind it, especially, and as I start going through the AI systems workload, I'll bubble up some of those questions. So this is really key now, that we bring in any CXL switch, any kind of a CXL endpoint data that people have, specifically for the workloads, even if it is from the micro benchmark perspective, it will be very helpful. So Sam, a very good point.
Right, because as you guys know, different workloads have different size of payload. Some are small payloads, some are large payloads. And people are, of course, familiar with moving data using DMA engines, using PCI and RDMA concepts. CXL provides .mam and .cache. It's very good to compare which workload, which packet size or payload size may or may not benefit from CXL, so people know which tools to use appropriately.
Yeah. Let's see if anybody in the room has anything that they're working on that they can bring forward in future from Meta side, at least not from Meta side necessarily. There is theoretical constraints that are being discussed in some of the documents out there. We can start from there, but it's really good, useful to bring forward some data. I'm sure as we at Meta also we'll continue to bring forward. We have presented the CXL.mem endpoint data before, and we have had a bunch of presentations and actual demonstrations in global OCP last year. And I'm assuming there will be more coming up in global OCP this year. We already have started getting query for it, at least already. I've seen a couple of them, right? Coming through.
Yeah. Yeah.
So any data, especially people who are already implementing in their products and already ready to test it outside, this will be a good place to discuss it. Okay.
Manoj, this is Ravi Kiran from Micron. So we demonstrated the bandwidth expansion use cases with CXL with software tiering. I've given this presentation in Linux Plumbers and even the CXL DevCon. How much of bandwidth advantage that we can extract from CXL at the system level. Probably we share the data here to see how bandwidth expansion can be done with CXL with various workloads. That might be an interest here.
Okay, so it's something that you can present to the community, I think. Okay.
And on bandwidth, again, sorry to go deep on some of these points, but so we don't gloss over important things. Bandwidth per watt sometimes is important. Per link, per lane, per interleave set, and then for the sake of what? For the sake of one single thread receiving a lot of bandwidth just to run one particular task very fast, or for bandwidth to get aggregate bandwidth for many threads individually, or cores or processing elements within a device running in parallel. Not everyone needs the maximum bandwidth, but in aggregate, they need a lot of bandwidth. So those are kind of important distinctions to make if the data is available.
Yes. So is this something that Ravi you can share? You want me to put some tentative timeline for that, just for the agenda planning for future?
Yeah, maybe for future, like in the first week of June or second week, I can come here and what we have.
Okay.
Yeah, the reason these things matter for composable memory systems is aggregate bandwidth would benefit from a fat pipe. You come up with something that's very high bandwidth. You take it from one place to another place, one chassis to another chassis. You compose the system that way. On the other hand, if people don't need a lot of bandwidth for individual processing elements, running a thread, multiple threads, multiple VMs, multiple cores within a device, then connectivity will be important. Topology, if you go from one device to many devices, each link might be smaller. In aggregate, they are still high at the system level, but maybe in that case, interleaving is not necessary. Those type of questions we can address once we know what the workloads behave.
Yeah. Okay, we have Vikrant. Hi, Vikrant. In fact, I was going to ask you the question. Perfect. Go ahead.
Yeah, no, I think this ties into what I was going to say around the workload benchmarks that we are running, because I'm running benchmarks and I'm running like Memtier and Cassandra benchmarks and whatnot. It would be good to have vendors present their benchmarks from a theoretical perspective. I think that, as Siamak said, I think that makes a lot of sense, because then we can see which solution actually benefits from what capability of the device, and how we can make these solutions or these components substitutable in each of these workloads. So I think it will be good. Happy to put a framework together to call out the basic like stream benchmark, MLC, spec CPU, whatever it is, the basic checkbox benchmarks that we need from these vendors. Because last year, I think there was reluctance to share numbers, but seems like all three memory vendors are now in a position to share at least some datasheet numbers. That'd be awesome.
So Vikrant, I think right now in the document, you do have some of these benchmarks put in there, especially MLC is there, I think, right? I don't know what's skipped or not. MLC and I think part of that is also specifying certain metrics to monitor. To CMX point, perhaps maybe we can look at them again from granularity level. Are we calling out all the things, especially if you're talking bandwidth, are we talking about bandwidth with lane specified, etc. So it will be good to take a look at that. Maybe CIMAC, perhaps you can also help on that to validate what we have currently documented. But this may be a good time to revive it and get the data, as Vikrant, you were saying, that, hey, if the solutions are out there, can we bring it out and talk about it? So that would be good on the cxl.mem. I would like also, as the AI systems discussion continues, I would like to bring up attention to cxl.cache also. And this may be something may not be that easy from the solutions available right now. But just wanted to bring it up that actually the way accelerators can access the data in CPU memory is only through cxl.cache today. Just architecturally, and somebody can correct me, of course, on that. If cxl.mem, if it can allow that in any way, shape or form to collect the data. I know we had the presentation from UIUC in this space and Intel, but anybody who has any other further data, that would be something that is really important.
Yeah. We also need to add the switching and pooling too. I know we have switching vendors. To what extent they can actually share.
So as we go through AI's use case, right? Because we had originally started with the general compute. The primary use case we had looked at was cxl.mem. From CXL perspective, at least that's the only memory interconnect that we had initiated in addition to DDR. And then the switch, as you suggested, for the pooled memory.
Right.
Right. Yeah. And on,
I'm sure you guys know CXL 3.1 has added two major features for moving data, but I'm not sure if we have any device that can exhibit that. The peer-to-peer.mem, for the sake of accelerators accessing data through a switch to an end device without having to go through the CPU, and then hosts reaching each other's memory using UIO for the sake of reaching a globally embedded kind of integrated memory, GIM. So those are features in response to some of these requirements for AI and HPC, but I'm not sure if we have devices that actually behave that way yet.
Right. Yeah, I think it'll be good to take the 3.1 features and say, if I were to have the CMS composable memory type of architecture, how best to leverage and exploit 3.1 features that includes UIO, back invalidate and all that stuff, and say, what does that architecture look like?
Right.
And see where the gaps are would be really a good starting point too.
Right, because again, some of these proposals and then solutions came in response to HPC, which is many systems, basically composable memory system concepts that we're talking about. Right. For moving the data using CXL fabric instead of using Ethernet fabric to go from host to host or from device to device. Now, it will be good to show how software needs to behave to take advantage of these.
Yeah.
So
Pankaj, you are breaking up. We cannot hear you, Pankaj.
It's LLM.
So do you guys hear me okay now?
Latency. Oh, now it's
much better.
Much better.
You
sounded like
were
alien.
super deaf, Punk.
Sorry. My laptop also suddenly just rebooted in the middle of the Zoom call. I don't know why. So I'm on the phone. There was two things going on. There was a bit of a crisis on the software side because generally for disaggregated memory and then particularly for computational memory, there is very little existence proof in current software stacks. So the whole approach that the CMS team have outlined of enabling some of these new features like CXL 3.1 features that CMAC is talking about, this requires, us enlisting software developers and the API work for this could not start sooner. So what we are doing, because the existence proof points are few, but the results are strong in some of these areas. What we are doing is we are encouraging, like in the academia work that I do personally, not in the academic team here, we are encouraging students to measure shared memory as a substrate for collectives and other things, and trying to see where the cutoffs are, like you guys were discussing, Manoj. When do you use which protocol? When do you stop using shared memory for large? So we are right now collecting that data. David Bowles from ARM and I, we did a little bit of looking together on this and have some early material. And then on the computational side, the people who have actually built CXL endpoints with compute and done measurement generally have single endpoints, Siamak, and are not in a position yet to evaluate peer-to-peer. So we will keep track of that and see when is the soonest we could get those measurements that you are seeking. But our team, CXP team, just quickly, last point, has switched to a weekly cadence from bi-weekly cadence in light of some pressure to examine more of these topics sooner. And so on 21st, we are actually changing our meeting time from 1 p.m. to 4 p.m. so we can get a team from Korea to speak with us. And we are trying to keep tabs on, all the teams that are actually doing evaluations and collect their data and their best practices so that we can capture into an API and enlist software developers to hit the milestones that we are seeking, where it's a stepwise process right now.
Okay. All right. So I think we'll schedule some time, perhaps in the next few sessions, for you to cover the collectives work that you guys are beginning to explore. Looks like, as you said, this seems at this point at least, how do I say, experimental at the best, right? Because the platforms aren't available, but to pave the
Yeah.
way, right? Okay.
Yeah, I mean, I checked in the industry, Manoj, with Microchip and Astera. So I had point meetings one-on-one with the senior people in product and engineering to see anybody putting any kind of computational elements. And very much in the industry, in the SOCs at least, the current state of affairs is people are working on their CXL2 parts. These are, basic dumb parts with load store and, CXL.cache is also hard to find in real parts, for example. It's all
Okay.
.mem, right?
Okay, perfect. Sounds good. Thank you. So let's put that some for the agenda also, maybe second week of June or first week of June, whenever you are ready for just kind of giving an overview to the day.
Yeah, second week of June
Okay.
is good.
Second of June. Okay. All right. Okay. All right. Hey, one more thing I wanted to cover was in the Tech Day Summit, I know we had covered a lot of content and there were some action items taken. I think Nara had captured those. Nara, do you want to share them and talk to them? Some of them, like I did get it from you. I'm going to paste it in the meeting minutes.
Sure, Manoj. Let me see. Okay. Yeah, I think like we had, depending on the discussions, there were some major action items and follow-ups that we had captured. I think during the AI HPC systems and fabrics session, there was one. I'm just going one by one, like as I have captured. Please feel free to suggest and we can modify as well. So one of the action items that was captured was like to sync with the working OCP groups where we have like overlaps, specifically with the FTI on group working on optical interconnects. I think this was specific to Manoj, yourself and Samir, presentation talk while we were going through the challenges and the interconnects and different protocols for AI systems.
Yeah, I think
Okay.
that is the short reach optical interconnect
Yeah.
working group activity.
Okay. Okay. All right. I'll take the action item. Reddy, maybe if you know also, maybe you can bring them into the discussion here sometime.
Yeah, I'm also working with optical vendors. Let me see if they're interested in actually coming in to share their views.
Okay. That will be good. So we can work on the agenda for that offline then, Reddy.
Yeah.
Cool. And I think like as a whole like group, we captured certain action items or 5 major action items from the takeaways from the discussions, the first half of the day discussions that we had. And the first one we captured was like with respect to AI, HPC systems and fabrics again, we need like clear mapping of use cases to be documented with white papers and specifications to articulate this as well. So I think this was mostly based on like the workload work stream. We need mapping of use cases to the like hardware specifications, architecture, and other things that we have, as well as cleared. I think the next one, which is related to it, action item, is clear definition of key metrics for AI and compute use cases. Those were kind of interrelated. That's why I'm stating them together.
Perfect. So this is something that we take for the goal planning basically.
Right. I think in the workload workstream, we have already started to discuss this, like I think last week. From this, after we had a sync after Tech Day, and we started discussing about key metrics for AI and computer use cases, or the direction where how to take.
Okay. And then I see system architecture, similar thing that we have to get the changes. Once we have the AI HPC systems use cases mapped, I think that flows into Reddy for the system architecture changes.
Right. Yeah. Let's follow that flow. I think maybe for the next couple of meetings, if we can settle on that would be great. Mapping
so
it to the memory buffers as well as the cache plus the
so
pooling.
we'll start with the AI HPC systems follow up based on the discussion we had. So we'll start today now.
Right.
Okay, there was one more item, looks like Nara, data locality independent scope of AI systems memory and data co-placement.
This was based on Pankaj's presentation on the computational programming. I think we discussed about the data locality to be independent for scope of AI systems, and a few like discussions on the data co-placement as well. I think like we need to have deeper discussions. We did not have enough time on the tech day.
Yeah.
Okay.
I think the discussion was also along the lines of there seems to be some research activity plus looks like some there was some response from the device vendors as well, saying they are looking into the the constructs needed, programming constructs plus all the others to enable the compute closer to the media. So I don't know,
That's
Pankaj,
right.
if you have any visibility there.
Right, Reddy. So let's first clearly capture the action item. The action item appears to be that between mailbox and non-mailbox mechanisms, like having to engineer a queue pair like interconnect for reasons of speed of communication between host and offload device. There is some suspicion that mailbox isn't right. And we needed to discuss this with CMAC because a lot of people right now are engineering kind of load store based mechanisms, including the UI/UC team. We'll find out from the other Korea team what they have actually done for their compute offload using memory mapping and memory map threads. And we are documenting right now what we see, but we would ideally, like to use a spec mechanism like mailboxes and capture requirements on mailboxes instead of something that is not in the spec. That would be extremely disruptive to success.
Right.
Okay.
Yeah. I don't know if Nara, if you have captured this, but there is a dire need to actually finalize the control plane operations needed for the computational offloads. I think this came from Pankaj as well, Pecan. We just don't have a good way to express that, the need and where, the location aspect and what need to be executed. So
Well, in addition to that, some standardization probably is necessary for
yes,
dealing
absolutely.
with concepts of interleaving, compression, encryption. If the data is encrypted, how does the computational element know what to do with it?
Right.
If it is compressed, what algorithm do they need to use to decompress it and recompress it, perhaps? And if it is interleaved, man, how do they find where the data is to deal with it? And if we don't interleave, do they lose performance? And that's related to the point I made earlier, that maybe we do interleaving in certain cases, we choose not to do interleaving in some other cases. And is it possible to have an interconnect programmed a particular way, certain workloads be interleaved, certain workloads not be interleaved? What does
Yeah,
that mean?
Siamak, these are really great points because they came up in our team as comment from Matt Soberg of Marvell, where he asked the question, should the scope of CXP team include type 3 devices? Okay. And it's exactly because type 3 devices occasionally have transparent compression and transparent encryption features or inline encryption features of various kinds enabled. So you still need to control them in the sense that Reddy was talking about in a standard way. And we found in talking with 0 point people, for example, and Marvell people, that there is some need for standardization of, like, compression window sizes or compression dictionaries or whatever it is about that IP, even a transparent IP that you want to control, and how would you discover and configure it, etc., in the sense that Reddy is talking about. Okay.
Right.
So yeah.
Pankaj, I didn't mean to interrupt, but I think just want to make sure that we have enough time to kind of focus discussion on that. We may not be able to do that right now, but I think just capturing that action item, saying that, hey, let's schedule the time for this. And I'm sure there's a lot more detailed discussion in the CXP workgroup that is happening on this topic.
That's right. That's right. But we found that its CXP group internally cannot resolve these, Manoj.
Yeah. So let's bring it up here.
Yeah.
Let us
Okay.
definitely bring it up here. Just from use case perspective, I think this is a good timing because one of the action items that we did come up with, well, actually, we discussed was to make sure that CXP work is connected well, or all the group works is connected very well with each other. And I think this is one of those topics also, saying that, hey, make sure that how does it really jive with all the work that is happening from the AI system perspective, general compute use case perspective, and potential ways it can be used in the AI systems, like what Siamak was pointed in the beginning for that use case. So we'll have to have that discussion.
And Manoj, from a meeting process point of view, how would you like to conduct that?
So I would say that at least first, let's make sure that we have a clear agenda added to the agenda item. Okay, and ideally it will be good if you, Pankaj, if you want to send out some kind of a outline for discussion, that what you're looking for, how you're looking for the inputs from that team. Because
Manoj, may I suggest that we use the forums we have to identify these cases and issues and concerns, but I recommend we not jump into solving the problem, because maybe the team eventually decides the problem needs to be solved in a different standards body. So we can come up with requirements, because this is a very large, nice expert team that we discuss these things as far as the problems. But then maybe you decide I don't know, a software organization or a hardware or specification organization needs to work on it.
I agree with you. Essentially, we are we want to make sure that I think now the second half we start driving specific things for the goals that we have for the teams, but anything that is much more detailed perhaps needs to be discussed in the work stream. But we can talk about high level problem statements.
Yeah, Manoj, actually, to add to what Siamak and Pankaj are saying, like very specific actions in the next 3 weeks, actually, we are preparing to draft 2 ECNs at the JEDEC CXL spec and then 2 at the CXL consortium. So actually, we do want the feedback from the broader team. So we've spoken individually to a couple of controller vendors and memory vendors, but I think it will be good to have a broader review before we go and file these ECN, right? These are very specific things talking about encryption, coexistence of compression, coexistence with RAS. So it's not just the computational elements, but how they coexist with the existing infrastructure that's already there in JEDEC and CXL consortium.
So yeah, I think Shailesh, this will be a good forum for us to make sure that we can build the demand and necessity for it in this forum, because it's an open forum and also it's driven by the what is the use cases. So as long as we have that, I think we can put it in that context and discuss it here, saying that, hey, for end use cases, blah, 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 that we are talked about, these are the requirements, and then get the group to understand what we are proposing and get a larger buy-in into that. So definitely that's a good one. The first time I heard about it, so I don't know the more details on it. So yeah, I don't see why I should not. Maybe do you want to send out something to the team first, just as a kind of a
sure
overview of it?
I can start a summary of the ECNs that we are planning to file with a couple of other partners, and then maybe we can schedule like a brief.
Yeah, we have to be a little. There's good thing and bad. One good thing basically we can use for this forum is that, hey, it can put a context of use cases why this is required, and you can champion for it in this forum. It's an open forum. Where we have to be a little careful is basically when it gets down to the details of specification changes. Some of these changes are under NDA in those bodies. So you want to make sure to be careful a little bit there. So anything like, for example, JEDEC will be under NDA. Within JEDEC, you cannot talk about what, just the way it is. I can control, those are the rules for them, right? But you can talk about, where you want to influence JEDEC activities from, and that is open discussion, not necessarily saying whether JEDEC is working on it or not is not something that we can discuss here. The second part is basically if there are technical details, it may be the same people who will be there in JEDEC also, but then there's going to be a limit to which we can have any kind of meaningful progress on in this product. So just a little bit, how to say, heads up on that when we get in there.
Related to that is the discussions we began with SDXI team. So this exact issue came up, which is we were not, some of us were not members in CXP team, and SDXI team said they are working on standardization beyond data movers, meaning they're working on APIs standardization beyond just data movers for Intel DSA or this type of device. So they're looking at some computational use cases, but they were not prepared to discuss it with people who were not members. So the way Nilesh and I have rectified that is Nilesh was already a member and is in touch with the people. I joined as member through UC Santa Cruz, okay? And we are kind of using that to pinpoint the discussion between CXP and SDXI on aligning on API work, so that specification happens in SDXI, not in OCP. But principles and such things can be agreed here.
Yeah, we should bring it back at least in the team, saying that not to make sure that we connect it to the work we are doing. That's all, right? And I think maybe I don't know the details, so I can't just comment generically on this one, and I'll let everybody speak. And this should not be just my thought. But perhaps I think next time when we talk, Pankaj and Shailesh, we may want to give the context to the team why we are, because we talk about everything with the context right now, right? Hey, the reason we talk about memory expansion because it is relevant for the general compute as well as AI use cases, and we say it in this way. So whatever work we are doing, we want to put it back into the context. So maybe perhaps for the next week's meeting, we can talk about high level, not the details, but why we are doing something and who are we working with and what are we expecting from this group.
Got
Right.
it.
I think we
Maybe I
had a
can work
slide
with,
on this in the CXP deck, but we can definitely give it better
Yeah,
time, more focused time.
level it up and actually maybe just kind of get everybody to see what exactly we are working with, which group or what.
Okay.
yeah, maybe
But not the
Pankaj, I'll
details.
work with you on the other JEDEC and CXL consortium item. Maybe we can summarize. And I think, Manoj, you meant Nilesh, not Shailesh, but I think I
Oh,
know you.
Nilesh, yeah.
But yeah, sure. Thanks. That's good clarification.
Yeah.
So Manoj, I had
Okay.
a more mundane comment, but it's one of the things that concerns me, and it's, I don't know, maybe it's action item, is that in the AI systems fabric presentation, you and Samir presented a very aggressive timeline to get certain things done. Is that topic of discussion which you wanted to move on to?
Yes, I do want to, and I know we
Awesome,
have.
because I'm really concerned about that timeline. So
yes. So okay, guys, if you guys are okay, let me move on to that topic. Samir, are you online? Let me just check because he's been pretty quiet. Yes, Samir is here. All right.
Sorry.
Okay.
Just last one. So basically,
Okay.
like I think we had one more where we are, like wanted to connect across multiple CMS work streams and how to, get in alignment with vendors and the use cases. That was the last action item that we discussed. That's probably more relevant for this forum. But yeah, just want to mention that we can take up next time. Sorry to interrupt.
No, that's good. Yeah, I need to. I'm still trying to think about. I know I thought I could understand that one. That was in the context of the optical interconnect. Now I'm trying to see how that would. But maybe you can take it offline and talk more, and then bring it back again, Nara. That
Sure.
one action item.
Sounds good.
All right. Let me go to the presentation that we had. Okay, can you guys see the presentation?
Yeah.
Okay. All right. Is Samir, are you online? I mean, I see him, but maybe he's multitasking.
Yes, Manoj, I'm
Okay,
here.
All right, Samir. So this is the deck, and I think so. What we wanted to do was we had talked through the why part of it, and then now specifically what we wanted to discuss here for work streams in CMS. The whole point was basically for composability. We need expectation here is that you have a tier 1 memory and there is a tier 2 memory that you want to compose it as a total solution for the system and the application. In this case, specifically focusing on the AI systems. And we had talked about how to give that tier 2 memories. What are the two tier 2 memories solutions are there? And we talked about something that happens in a node native, which is in the context of the single accelerator, and then fabric attached, which is across the accelerators or the fabric attached. And then the next thing was basically take that and map it into the work streams, discuss it here. What work streams do we need? What specific categories of work that has to happen for completing that? And then to Brian's point, extremely aggressive timeline that was put it in the red just to be more, how do you say, excite the response in it in a way so that we can get a pushback on, then we can get some realistic numbers on it. All right, so that's what we had kind of rushed through during the meeting. So wanted to take time and walk through it and just make sure that, we are good on that or identify areas, because there were some things that were pointed to me after the meeting that we think this is a good time for us to capture it and make sure that there's clarity on it. Samir, anything else that we want to achieve? Yeah.
Yeah. I think those deadlines that we have put, they are aggressive, but I think we need some deadline. Otherwise, we'll not make progress. And let's try to achieve. And for that, we need some focused discussions from now until July, so that we can close on it. I have started on it. I have some very rough 3 slides I can show today, if possible. And let's at least have a kind of a vision what we want to accomplish through that white paper, right? And if you all agree on that, then the writing is the part. But let's at least have a common vision in mind for this AI systems.
So guys, what makes this specific to AI systems? It seems that these concepts and the diagrams are very generic.
So I'll start with my view, and then Samir, you can chime in also. We have looked at it from the general compute perspective, and we spent some time last year saying that, hey, if the memory is expanded as a tier 2 to CPU versus tier 2 to HBM, or sorry, no, tier 2 to accelerator, because the applications that are running, where are they running is the difference. If the application is something that runs on the accelerator and it is using tier 1 memory, which for example is HBM, which is inside the accelerator, and then it wants to have a tier 2 memory, versus an application that runs on CPU has been using some DDR attached direct memory as a tier 1 and needs to have tier 2 memory, which is what is maybe CXL or anything else. So that was a difference, but I'm sure, Siamak, since you asked the question, I'm sure you have deeper thought than that, because this is the obvious answer I'm giving.
So, Samak, to answer your question, yeah, if you remember what this group has accomplished on the CPU-centric platforms, we want to use the same template and focus on GPU-centric platforms and memory expansion, and then maybe eventually looking at pooling and sharing with the GPU at the center. Right? That's the goal.
So the use case is different, but will it cause differences in the way we program these devices or the way these devices behave?
We can go through each one of them and see. They do, in my opinion. For example, if you take tier, let me start with this and maybe let's see if it takes it further. In fact, this may be a good leading question for that. So if you take a first saying that had a tier 2 memory for application that runs on a accelerator, this could be anything that is actually the job that runs inside the accelerator. Keeping in the context, of course, that CPU is triggering up some of those things. They're getting offloaded to the accelerator. If it is a GPU, this may be a graph that gets uploaded to the accelerator, and then in that process, they need memory that runs. Today, they could be just taking the memory on the HBM, or they could get, if they want, they can get it. If they wanted to get additional memory, how do they go across some place, whether it is attached to the CPU or whether it is attached directly to the accelerator? In some accelerators, they support it, or it goes across the interconnect and get it from other GPU. That's different than, theoretically, it could be something that could happen to CPU also, but we are just putting it from the perspective of the accelerator. So here in this case, you could have a memory that is attached to the CPU. The way it is changing is basically, how does accelerator have access to that? Typically, accelerators are endpoints. If you take the PCI CXL kind of a implementation, as compared to CPU tends to be a root point, and CXL.mem is very natural thought of how to achieve that secondary memory. For accelerator, it is different. Theoretically, it is possible, I guess, in CXL.mem. I'm not quite clear how, but most of the time the way I look at this, it will be, if you want to access the memory that is attached to the CPU, is CXL.cache. So fundamental way to achieve tier 2 memory in the case of CPU versus GPU are two different mechanisms. Let me pause there and see. I would love to hear from you.
Again, it's very good. I will repeat the comment I made earlier. It's very good to articulate the use cases and come up with perhaps requirements that this team can come up with.
Yeah.
But for the solutions, we need to go to the appropriate standards body. For example, some of the topics that perhaps you mentioned, Manoj, a minute ago, are being discussed at CXL Consortium as post 3.1 spec work. In other words, how do you have an accelerator that can have local memory or whatnot, and what type of links there should be? Is it a root port or not, or those type of things? So maybe that's the generic way I wanted to express that.
Oh, you're absolutely right. So I think the actual how to achieve that part will happen in the specification or standards body like CXL. Where we are coming right now is saying that, okay, if I have a use case like this, is there something that I can use it? How do I use it? How do I make sure that I measure it, express the performance for the application perspective? So that's where actual, if the support doesn't exist, we may put that at the most as a, hey, this is the end user requirement and go, let's see Excel or JDEC or whichever body is working on it and make sure that we provide the inputs into it.
Right, because you guys know that, for example, CXL has a very strong software and systems work group that try to address some of these things as well. Some of you guys are part of that team already.
Right.
So it's just making sure the work is done in the right place, so it's documented the right way.
Absolutely, absolutely. So this is where we are expressing the use case still. They're saying that, Node Native is saying that, hey, I have an accelerator, it needs more memory. This architecture is nothing new. Grace Hopper allows you to do this today from NVIDIA. You can do that with PCIe with any accelerator today. You can access the memory that is attached to the CPU. No cache coherence in this case. CXL.cache if you wanted cache coherency, and then there are trade-offs and Infinity Fabrics or any other solutions that are available out there. But this is a use case for AI systems in the sense applications will need that applications need more memory than HBM, and they need tier 2 memory. And the way to get that in one configuration, system configuration, is to attach that memory to CPU. Samir, anything else that you want to focus on that part of the use case?
I have a couple of slides I just drew. They're not complete, but
I'll stop sharing and you can go ahead.
Yeah, 1 second. Okay.
By the way, while Samir is sharing, are we limiting accelerators only to GPU? And so is that kind of the idea? So we exclude all other custom accelerators?
No, I don't think so. It's as long as it's basically we have to articulate it. We can't exclude unless we know what it is, for sure.
Can you see my slides?
Yeah.
Okay. Again, I just drew it in last 10 minutes while we were talking. So nothing is complete, but I think it's good for some framework, and we can refine this. So this is what we have today, right? This is where GPU in mind. We have PCI switch, and the CPU is on the top. There is a DDR, and this is the path that GPUs take to get any data out of storage, goes to DDR, and then finally goes on to HBM. We are all aware of that, right? Now, if you look at what is available in public domain, for example, Grace Hopper architecture, everybody is aware of this as well, right? There are two GPUs. They have their own interconnects. Now NVIDIA has NVLink, and now we have HBM and LPDDR. LP is accessed through Grace. So I have not drawn Grace here, but just think of it that we added a secondary memory to GPU through Grace. So this is what is available through NVIDIA's Grace Hopper, right? Now, what we want to move towards is this one, right? For example, what we are saying here is now we have a CPU. What if we introduce a low latency switch? And now, if you can imagine everything that we have done on the CPU centric platform, right? Most of that work can be carried over here. I want to keep interconnect out of this discussion, just because we are not just the interconnect kind of focused here. We are focused on composable memory systems and memory disaggregation, right? So let's not bring interconnect for time being. But is this something that buys any value, right? So we have GPUs, we have some kind of a low latency switch behind some interconnect, and we are adding LPDDR and DDR. So the point here is that you don't have to go through the CPU to access the memory. You can directly access, GPUs can directly access. So these are some ideas, and we all need to go through this, find out what are some of the challenges. For example, in the current CXL, so in the CXL.man, it's only CPUs that can initiate reads and writes, right? But now if you want to do something like this, if you just stick with type 3 kind of devices, then can GPUs do those CXL.map, right? So these are some of the challenges, and we all can go through this and find out what are the pros and cons, and we can just write all these things in the white paper that is coming, right?
Samir, just again to help out here, again, you said you didn't want to specifically talk about any particular interconnect, but the one I know, the CXL 3.1 addresses exactly what you want. If this low latency switch is in fact a CXL 3.1 switch, and those LPDDRs are memory elements, GPU can directly touch it using direct peer-to-peer.mem. That is the new feature of CXL 3.1.
Okay. So yeah.
I think, Samir, what you're saying is basically, if we take the use, and sir, Grant, I do see your hand, I'm going to get in there. What you're saying is that for the first use case, we're expanding the memory natively for the accelerator. But you're saying that there are multiple options available, and you're showing those options, and there needs to be discussion on those, what capabilities is available today, and maybe what capabilities are being planned that we know of. But first of all, at least put the system options on the table so that we have clarity on what is there and what is not covered there.
Okay.
And Samir, question with regards to this LPDDR, is that DDR connection into the switch, or is that a
yeah, that's why I said we need more discussion on this, because this is a very high level picture that Samir has drawn. There's a lot more details about what exactly is the connectivity between what.
And is there a need between, for communication between CPU and GPU in this switch model, or is it just a multi-headed memory?
Yeah, we need to have that. So as I said, we'll have to name and label everything in this picture as we go forward, so that we can have a clarity on that. But I think what Samir is doing is basically providing that, hey, even though I drawn a very simple picture of saying that I need a tier 2 memory going across CPU,
it makes sense
a lot more
where we are today. Yeah, where we are today and where we want to be. I think the details will be good.
Yeah, exactly.
Hey, Grant has been waiting patiently. Sorry about jumping into the queue.
That's really nice of you, patiently. I'm staring at everybody in my camera. So one thing that I wanted to add is that, like, we've been spending a lot of time on hardware diagrams, and I think what we need to start adding to these conversations is what actually links the things that use these hardware diagrams, right? Like, we haven't talked about software hardly at all. And like beyond like a Grace Hopper architecture or Blackwell or something like that, where they have all of this sorted out for NVIDIA's own proprietary, they have all of the software layers that make it useful to the people who are using the hardware in general. And so like CXL and, in some ways alternate Ethernet is a pathway to like putting together a not vendor locked in NVIDIA cluster, but there is no software discussion at all going on about how to link these together such that an application developer can actually utilize these resources. So I'm wondering when we're going to start to talk about that as well.
Yes, and just to add to that, I think the whole framework for stitching these things together, which is basically the whole fabric management aspect of it also. So some of these things will start with these cartoon pictures about system configuration that we need to talk about, that translates into the system architecture diagram that connects the various blocks from the CPU side, GPU side, or all the components that we are putting in there. And then the third part that comes up is basically the fabric orchestration, at least. Now, the software components, I think we need to, some of it we have done, some of it we have not done. So we need to think through it. For example, when we did it for general compute memory expansion, we do want to, because the whole point is hardware software co-design for this team. So we talked about TPP, transparent flash placement, and other components that ties these things together. We need to have the same discussion. The reason I brought up CXL.cache was for that aspect, that it does allow me to expand it from the accelerator. and this is why we had the discussion with UI UC before. So yes, short answer to your question is yes, this is hardware software co-design. We do need to identify the blocks that connects it.
And I do encourage anybody with software expertise to also join this discussion. And exactly, we just don't want to limit ourselves to hardware and not focus on software.
So
That's correct.
And like to add a
In fact,
second
general comment from a software perspective here, and I don't know the right, what the right way to depict this is that the programming models here between these computational elements are effectively completely disparate, right? So inside of a GPU, the runtime environment that my application code has to sit down on, right, is completely different than the runtime environment that I see up on the CPU, right? So down in a GPU context, I've got basically the scheduling and the memory management are in lockstep, right? And if I want to continue with this sort of industry trend of saying I can't ever change my programming model, that reality just does not exist up on the CPU side. And there's a tremendous difference between what you can do in each of those realities. And they're completely different.
True, what you can do are different, but what we're trying to, I'm a hardware guy. What we're trying to do in hardware is basically do no harm when we expand the capability beyond a few devices to large number of devices. Let me try to explain. So if software guys are used to having one GPU connected to one CPU, maybe through a switch, and have local memory or memory off of the CPU, if they're used to doing that, and the programming models, as you said, although different environment running on CPU versus running on GPU, if they're used to that small hardware setup, when we create a large disaggregated system, we're sitting here as a bunch of people trying to recompose it so it looks exactly the same way that software guys want it. It takes some work, it takes fabric management, it takes security, it takes RAS and everything else, but we would like to preserve that feel. But you guys are the judge of it. Maybe we're missing something.
Well, so that's a good segue. And then I'm out. I'll quit monopolizing time. But like the Linux community, we can't discount that everything in the data center is Linux for the most part, right? And the Linux community is marching down a path of how to use CXL attached memory, just CXL attached devices. And I don't know how they're choosing to do that is a way that the rest of this group would necessarily agree is correct. And so like there hasn't been any sort of collaboration or outreach with those folks that are writing the driver stack, like overtly, right? And I think that's something that this group is.
I'll just jump in really quick. This is Adam from Samsung, definitely involved in the driver stack. And, that kind of collaboration, that's why I'm here, to kind of hear if there's anything actionable that we can do right now, right? And I can definitely share kind of thoughts, but the push has been now somebody come up with a type 2 device, right? Like it's all been on type 3 on memory. But if no one throws it over the fence, right? Like so the plumbing is there, but who's going to go and say, hey, I have a type 2 device and I'm willing to put some code out there and try to integrate with the Linux community? That's the question that has been on the Linux side.
So I think what I'm hearing is, yes, we have a bunch of hardware people drawing nice diagrams, but we need to be educated on all the software side challenges. So I would encourage anybody on this call who understands software better and come and work with us, right? And bring all those challenges, and let's see whether there is anything we can do together.
So Samir, you have one more slide.
Yeah, let me just finish
You
my
got the
last
feedback.
slide.
Yeah.
Yeah. And this is another thing where now we bring two GPUs and they have their own interconnect. Let's not worry about what that is. And then can we have this low latency switch and the GPUs can share the memory, right? That's one more kind of a vision that we have. But does this make sense? Does it bring any value? There are a couple of use cases we have been exploring, but again, what are the challenges? And all of those things has to come in that white paper. So
yeah. Oh,
So
I think
Samir,
so.
I want to outline a few critical questions that come from your diagrams. One is, I think the very important next step is which of these links, whether they are PCI Phi or not, are required to carry the CXL protocol versus it would be a nice to have CXL protocol. I think that's a really critical question for this group to say very clearly.
So let's do one thing then. Just kind of maybe putting a little bit. So for the next meeting, we will go into the details of these pictures that Samir has drawn, but let it connect it back to the use case, right? That we want to have a memory that is inside the compute box or a single GPU CPU context or single OS context, whatever you want to call it. And then there are multiple ways of going at it, but we'll mark them clearly for where are the buses, where the functionality is. Like for example, right now this shows that low latency which connects directly to the LPDDR with a DDR bus. Maybe there'll be a device like that, but clarifying it out, saying that okay, there is a switch and then there is a controller, whatever it may be. So we'll Samir, perhaps we'll work on it next week and then get a little bit more detail. Try to bring it to a generalized depiction, but maybe at the same time make sure that it is practically usable also for us in some short run.
Yeah, let's bring all the challenges listed.
Yeah. Okay. And in that context, we'll come back also say that hey, what we have, Meta will be happy to come back and say, and Microsoft will be also, I'm sure that there are what we know are the limitations ourselves, but we can start from there. We can have a good dialogue from there.
Yeah.
Okay. All right. Hey, good discussion. I'm looking forward to next week already. All right.
Awesome. Thank you. Thanks, everyone.
See you guys. Bye.
Thanks.
Thank you.